the subatomic particles in the atom, protons, neutrons and electrons, and how they are arranged. So, atoms and subatomic particles. So if we remember, everything is made up of really tiny things called atoms. Atoms used to be the smallest thing that we could think of. But now we know that atoms can also be split up. And they can be split up into protons, neutrons and electrons. Now, I've got some Play-Doh, which I'm going to use to represent electrons and protons and neutrons. The protons and neutrons are much bigger than the electrons, and they stay in the middle of the atom. So we might have 2 protons and we might have 3 neutrons in the atom, and they would be like that in the middle. If we've got 2 protons, we've always got the same number of electrons. So we would have 2 electrons outside, and we call that they're in a shell. Okay? Although it's static, although it's still here, what would actually be happening is the electrons would be whizzing round and round and round the protons and the neutrons. Because the electrons are so small, we say that the protons and the neutrons each have a mass of 1, and the electrons have hardly any mass at all. We count it as 0. So what we weighed here would have a relative mass of 1, 2, 3, 4, 5. That would be its mass number. Its atomic number is the number of protons or electrons. So it's got 2 protons, 2 electrons. So its atomic number would be 2. Now if we remember, this is a periodic table, and it's got a number at the top and a number at the bottom. Remember, the number at the top was the atomic mass, the number at the bottom was the atomic number. So that tells us how many, the bottom one tells us how many protons and electrons, and the top tells us how many protons and neutrons altogether. So if I wanted to make B, which is boron, I'm going to need 5 protons and electrons. Let's do that. So I'm going to make boron, which is going to have 5 protons, 3, 4, 5, and it's got to have 5 electrons on the outside, 2, and then there's going to be, because of the way it looks, there's going to be 3 of them flying outside that one. And then if we look again, boron has a mass of 11. So if it's got 5 protons, it's going to have 6, 7, 8, 9, 10, 11, 6 neutrons. So if I've made enough, it's going to have 6 neutrons, and they would actually go in between the protons. So I'm making it. 1, 2, 3, 4, 5, and probably 1 more, 6. Okay, so what I've made there is boron. It's got 5 protons, it's got 5 electrons, and you can see they're spread out. Remember, they would be whizzing around, and it's got 6 neutrons. So we can use the periodic table to tell us what the element will look like, what the atom will look like. If we wanted to make lithium, so it's got an atomic number of 3, 3 protons, 3 electrons. It's got a mass number of 7. 3 protons. If it's got to be 7 altogether, that's 4, 5, 6, 7. 4 neutrons. So let's see if we can make that one. We needed 3 protons. We needed 4 neutrons, because 3 and 4 is 7. That would be in the nucleus of the atom. Okay, 7. And then if it's got 3 protons, it's got 3 electrons whizzing around outside. Okay. Again, 2 and 1 would be outside, and these are whizzing round and round the nucleus of the atom. This is whizzing round and round the nucleus of the atom. Okay, so that would be lithium. I've made years back. This is how we normally see it looking, where we've got the nucleus with the protons and the neutrons in the middle. The electrons we often do is just like crosses on the outside. Sometimes we're asked to do a table like this. You can see protons are worth 1. They weigh like 1. Neutrons weigh 1. Electrons don't weigh anything. Protons have a positive charge. Neutrons have no charge at all. And electrons have a negative charge.